Hey everyone, welcome back to another video. In this one, I got a little inspiration from my cousin. He is creating a new series where he chronicles himself becoming a game developer. And in his first game that he was trying to make, he wanted to create Pong. So I thought it'd be a great idea to make Pong in Game Maker and show you all how I did it. I added some flair stuff to it as well. But you should really check out his videos. I'll link his series where he's becoming a game developer in the description. You should really check it out, especially for those of you who are trying to learn Unity. It's a lot of good stuff on there. You'll probably pick up a lot. So most of the code for this game is done in the step event of the ball. So right now we have the first lines are x plus equals x form, y plus equals y form. And this is really where the magic is happening for the movement of the ball. X form being the x transformation. Transformation just kind of being a fancy word for how we are changing the x and y values. So this is going to be, the distance between where the ball is and where the ball should be in the next frame. So down here, if we go all the way to the bottom, is where it updates. We see x form equals cos rad times speed, y form equals sine rad, negative rad times speed. And don't get too tripped up on this. It's pretty simple, and I'll explain how that works for those of you that haven't done something like that before. Basically, what's going on is when we have the ball, we have the speed at what we want to be, where we want to be going. And we also have the angle. So we know what direction we want it to be going. And we know the speed. So all we don't know is the x displacement, how far we need to move the x value, and how far we need to move the y value to get to this point, right? So we know we want to move at, let's say we're moving at 20 pixels per frame. We want to move in 20 pixels per frame, and we want to move at 30 degrees. All right, well, we know this information, but we don't know where we want to move x and where we want to move y. So if you remember from trigonometry, we got these handy functions, cosine. And what cosine does is it takes an angle, and then it spits out the ratio between the x value, or in trigonometry they call that the adjacent, over the hypotenuse, which is the speed that we're moving. That's the long side of the triangle. So in our case, in this example, we know that we have an angle of 30, and we know we have a speed of 20. We just have to solve for this x. So what we can do is multiply the 20 by both sides. So we can get x equals cosine 30 times our speed 20. So this is our angle right here, and this is our speed right here. And that's all we're doing. That's all that is. And so that will give us the amount of x displacement we need to go to get this 20. And then to do the y, we do sine, which is the same thing. It's the y over hypotenuse. So it will end up being like this. Pretty cool, right? So the thing about this, though, is this isn't totally correct. And as you remember from my previous videos, when dealing with video games in 2D space, we're not dealing with a typical Cartesian grid. So if you remember a Cartesian grid, if it was like this, the y value goes up. The numbers will get greater on the y-axis, and the x value goes this way. The x will get greater on the x-axis. But it's different in space of games. So it's more like this, and the y value is flipped. So the y value will get greater this way, x value this way. So in actuality, we'll have to take the negative of the degrees for sine, because sine function is built for a Cartesian grid system, and we're not using that, so we'll have to take the reverse of our angle. And in actuality, and we'll see over here, cosine and sine don't take degrees. They actually take radians. So before we can even do anything with them, we have to convert our angle. And this is the angle this variable angle is keeping track of here of our ball moving the angle that we want to move it. And we have to multiply it by pi over 180. Now, why is that? And that's how we get the radians. But why is that? So if let's make a new one, node save. So if we check out our classic unit circle, right? A unit circle is just kind of it's a circle that has one radius, and we can kind of solve degree and trigonomic functions using this as a model. So going this way right here, this is 0 degrees. Up here, right, 90 degrees, because if we did this, boop, boop, we would see that's 90 degrees. And way over here, whoa, like that, this is 180 degrees. So from here to here, we turn all the way around, it's 180 degrees. And in radians, which is the, and a radian, all that is if you took a radius, right, of a circle, and you took that radius and you kind of put it around the circumference, the outer edge of the circle, you would end up getting 1 radian. That's what sort of radian is. It's just the length of a radius kind of put over this guy. So what we got here is 180, but we have pi radians. Instead of 180. So that's it going this distance around the circle, we'd have pi radians instead of 180. So for every pi radians, we have 180 degrees. So if we want to convert from degrees to radians, all we'd have to do is take the degrees we have, multiply that by pi over 180, and you would get the amount of radians of that degree. So you could reduce this fraction. That's how you'd get that. So, ooh, where's my mouse? So we're converting our angles to radians because that's all that our cosine and sine functions will take. We're figuring out the x transformation and y transformation we have to go. And then we're making our image angle for our ball, the angle that we are moving. So it's always pointed towards where we are, the direction we're moving. Great. So let's go back up here. The first thing we want to do in our ball is check to see if we are going to be, if when we move, we're going to be colliding with a paddle object. And the paddle object is the parent object for both object of enemy and player. They are children of the paddle object. So when we look for a paddle object, anything that inherits from that paddle object, we're also checking against. I'm sorry, that's my alarm. And so what this does, instance place, is it checks the object that we're moving, and it checks at this x and at this y if there will be a collision. So we are temporarily moving it towards x form and y form. And if there will be a collision there, we will return the object ID of the collision, the instance ID of the collision that the thing we're colliding with for object paddle. And if if we're not colliding with anything there, then it will return no one. Next up, we are going to check if the ball's out of bounds. If we are out of bounds, we are going to play a sound, and then we're going to check if the sign of the x form, if it's positive, we're moving to the right. If it's negative, we're moving to the left, because that's how the x coordinates work. So if the sign and sine, all it does is it checks, it will return if this is a negative, it will be a -1. It will return if it's positive, it will be +1. And if it's not negative or positive, meaning it's 0, it will return 0. So if it's greater than 0, meaning it's going positive, we are going to, and we're out of bounds, Then we're going to give the score, global.escore, which is the enemy score, to the enemy because it's on the right side, the enemy's side. Else, we're going to give it to the player, and we're saying the player is on the left side. So it's P score and plus plus, just adding 1 to the left side. We talked about that in previous videos. And then we're going to create the effect, the FX explosion I made. Let's see the game real quick so you guys see what I'm talking about. So we have the ball, it's moving, boop, boop. And we'll do a little explode animation there. I'm sorry, the explode animation is kind of annoying. I didn't realize how obnoxious it would be when I made it. But so this is we're creating an instance at the place where the ball had gone out of bounds, and we're creating the explosion and giving the angle to the explosion. So usually you do angle plus 180, so it would be exactly the opposite angle. So when you saw the explosion, but I had already made the sprite for the explosion the opposite angle, or like 180 degrees more. So I didn't have to do that. But if you had the explosion at the same angle as the ball, you would have to do angle plus 180. And then once it's out of bounds and we've kept track of score and we've made the explosion animation and everything's good, then we will set the X and Y values to half the room and room width and room height, which is the kind of the game screen, the game level. And then we're going to reset the angle to a random angle between -80 and 180 degrees. And what that's doing, it's just saying that it can move at any angle randomly, because, there we are. All right. Because that's kind of like saying, but right here, this is both 180 and -180. This would be -90 degrees down here, and this is +90 degrees, and this is 0. So it's just checking, it's just trying to find an angle, or it's giving us a random angle between any of these points on the unit circle. All right. And then we're going to check if we had collided with the paddle previously. We don't want to keep colliding with it over and over again, just in case, because there's instances where the ball is kind of moving over the paddle, and if we keep moving up, we'll keep colliding with the ball over and over again, and we don't want that to happen because the sound effect will play over and over again. It will kind of jitter. So for about 200 milliseconds, we want to say, okay, after you collide with the ball for about 200 milliseconds, just stop colliding with the ball. We're just saying the time, because in collision down here, we set the previous time, which is current time. That's current time in milliseconds, subtracted by the current time minus previous time. That will be our elapsed time in milliseconds, which I call delta time. If delta time is greater than 200, meaning more than 200 milliseconds have passed, then we're going to say colliding equals false. And if colliding is true, then it won't let us collide again, because this if statement checks if we are colliding with the ball if instance exists paddle. Because remember, back here we checked if the paddle is being created, and we aren't colliding because exclamation point means not. It's the not operator, not colliding. Then last hit, we keep track of what we last hit, and then this right here, basically what we're doing is we're taking the difference between the paddle Y origin and RY origin, and then we are getting the half width or the half height of the paddle, and we are storing what direction we want to go afterwards, the base direction we want to go, and if we're hitting to the left, let me see if I can describe this. It's actually a little more complicated to describe than I thought it would be. But we got a paddle right here. We got our ball right here, right? And we want the direction of the paddle to be dependent on where it's hitting on, or the direction of the ball to be depending on where it's hitting on the paddle, because we don't always want it to hit and, you know, bounce off the same way. We want to give the player and the enemy some control over where the ball hits off. So if it hits off, you know, way to the right, we can do like a full, you know, 45 degree, negative 45 or 45 degree bounce off. If it hits in the very center, we want it to be like 0 degrees, and then it can, like, you know, bounce right off straight up the straight line. And that way we give the player some control over how the ball hits off the paddle. And so how we do that is we take the difference between the distance of the paddle and the ball, and then we take half the width, and we make those a ratio. That way, if the paddle ball is all the way on the top, the ratio will be, you know, let's say the paddle's 25, the half height is 25, and let's say the distance is 5. Then that will be, you know, some number, and then if it's 25 over 25, that will be 1. So if it's 25 times 25, we'll then multiply by the angle we want it to be, so 45. And so if this is 1, this will be 45. If this is 0, this whole thing will end up being 0. And that's kind of the basic principle, but we're using the lerp, which is a function, which is linear interpolation. And lerp function, it does kind of the same thing, but it takes the starting value you want it to be at, the ending value you want it to be at, and the percentage that we're at. So that will be this guy, the difference over the max height. And because this can be from 0 to 1, and that's kind of a percentage. It's like saying from 0 to 100%, because like 0.5 would be like 50%. And then it will take the percentage between these two numbers, 0 and 45. And that's what we're using to see how far up or down we are on the paddle, and then making that degree between 0 and 45 as a percentage, where 45 is 100% and 0 is 0%. And because the difference, if we go down, is going to be negative, because the paddle ball will be, y value will be higher than the origin of the paddle, it will become a negative value, and this will be negative 45 degrees. So it will bounce off this way down here, or this way up here. And I hope that's understandable. If you have any questions about that, let me know. So that's what we're doing here. And if we're coming from the right, because remember we're checking the sign of the X form, so we know we're going right, then we want it to be from 135 to 80. Because that's going from the left, like the right to left, that's the same thing as 0 to 45, 180 degrees minus 45. And the pitch, we're just setting, the pitch is for the sound effect for ball hitting, because I want the sound effect to be a little lower when hitting the enemy. So pitch 0.8, 1 is normal pitch. Anything less than 1 is going to be a lower register pitch when we play the sound effect. So we have that angle, and we have that lerp that we talked about, linear interpolation. Very powerful function, used a lot in graphical programming. And then we're going to keep track of the sound for the boop, called the boop sound effect when the ball hits the paddle. And then we're going to play that sound. We're going to change the pitch of that sound effect depending if we're hitting an ally or an enemy. We're going to say colliding is true, and we're going to set the current time, so we can check against the previous time, so we can check against the current time later, so we can check the time elapsed in milliseconds. And then all we're doing here is we're checking to see if we're hitting the roof or the top of the game room or the bottom. And then we're just going to do negative angle. So if we're hitting like this at negative 45, it's going to go to positive 45. So when we're hitting the bottom, it will just bounce off normally in negative angles. And then we do that stuff at the bottom we told you earlier, and that's everything for ball. And then for the enemy and player, I just check if I'm moving up or down, if I'm clicking the up or down key. And how this little bit works is I'm taking the speed. So our speed is 10 pixels per frame. And I'm saying, okay, if you're clicking down, because these either come true or false. And what true or false really is, if something's true, it's 1. If something false is 0. Anything above 0 is true. But how these register when they return, when I'm like, oh, I'm checking if I'm pressing the down button, is they will either return as 0 or 1, 0 being false, 1 being true. So if this, for instance, is 1, if I'm pressing down, and this, for instance, is 0, this will be speed times 1, because 1 minus 0 is 1. So I will be going down, because as we add to y, we go down. And if this is 0 and this is 1, then we will get 0 minus 1, so it'll be negative 1. So it'll be the speed times negative 1, so we'll be going up. And if these are both 1, then they're going to subtract each other and become 0s, and then we're just not going to move at all. And then we're going to add speed plus equals to y, and we're going to inherit, because if it inherited is just we're inheriting from the paddle. That's our parent. And that's really the entire game. We do have a score object, and it keeps track of some global variables and draws the text for the score. And that's about it. That's the entire game. That's how everything works. So now if you can see... Yep, and we have that little effect that happens if the ball goes off. I thought was pretty cool. All right. And that's about it for the game. You could add some other stuff. You could add, like, if you get so many points, it says game over or something like that. There's a lot of stuff you could do with this concept. I mean, it's Pong, so there's a lot of stuff that has been done with this concept. But like in Game Maker, there's so much you could do and experiment with. So if you end up creating something like this, experiment, do some crazy stuff. Maybe if you press a button, the ball can split into some other balls and they all move in some random direction. You know, you can like do anything. The sky's the limit. Yeah, so that should be it for this video. If you have any questions, like always, please ask me. I am always excited to answer questions about anything. If you think I did something wrong, if you saw some flaw in anything, or I said something wrong, let me know. I would love to correct any mistakes I make. All right, thank you so much. I hope this was somewhat helpful for you, and have a good one.